My name is Eric Carlton. I'm an engineer with the National Precast Concrete Association. Today I'm at Champion Precast in Troy, Missouri to talk to you about cage fabrication. And with me today is Michael Gamble with Champion Precast to talk to you about proper cage fabrication here at Champion. Good to have you here with us. First off, it's always important to make sure that you have the proper PPE handy anytime you're around the plant production. Structural reinforcement is critical for concrete. As you know, concrete is very good in compression, however, very weak in tensile forces. The reinforcement is what gives you the combination to make sure your structure will handle the loads in the ground. So Michael, what type of reinforcement do you use at Champion?
Here at Champion, we do primarily rectangular and round cages. As far as rebar goes, we use mostly number 4 bar and number 5 bar. But for today, we'll focus more on rectangular cages.
Before the crew begins, it is critical for them to look at the shop drawings to ensure what they are going to be building and what the steel will be required for the day. A lot of times shop drawings can call out the steel in 2 different methods. One of them is very prescriptive, where they'll call out specifically, like here, number 6 bar at 4-inch centers. Otherwise, another way to call it out is the steel area itself, where the crew needs to calculate what it would be. That would be like 0.36 square inches of steel per lineal foot of wall. I suggest that you check out our Learning Lab video for precast reinforcement inspection to give you more information on how to calculate reinforcing steel. Another important aspect in the drawings should show what the tensile steel is required to be used. Tensile steel usually comes in 40,000 PSI or 60,000 PSI. It's certainly okay to utilize a tensile steel greater than what's required, but it's a real problem and not to be used to use a tensile steel less than what is required.
All right, so now we reviewed all of our drawings. Let's go ahead and start making our cage.
That's great.
So today we will be building a 12x6 cage for a 12x6 utility vault.
Excellent. The first thing the crew needs to do when they're going to be choosing some rebar is to inspect it to make sure that it's free of pitted or flaking rust. A little bit of rust is okay. The other thing that they'll be looking for is the markings on the rebar. It will tell you the number of bar that is on here, the size of the bar, and the manufacturer of the bar, and also the grade of steel. And it will tell you if it is a US made or foreign made steel if your project specifications require it.
So for a typical cage layout, there are straight sections and bent sections. So some shop drawings may include a bill of materials that shows the exact number of each individual rebar size and cut length. They may also show a bend detail for the precast structure, while other drawings may not. If the shop drawing does not show a reinforcing steel bill of materials, then the plant will need to develop one on their own.
That's great advice, Michael. When constructing a fabricated cage, you'll need multiple pieces of rebar to get the peripheral length of the cage that you're going to be manufacturing. To do that, you're going to need splices, and there are 3 primary ways to do splices. One of them is the overlap method for reinforcing steel. The other method is a structural weld, and the third is a mechanical coupler to bind them together. The most common in the precast is the overlap method, and that's what we'll be seeing today here at Champion. When a lap splice is required, the minimum overlap of 2 adjoining steel reinforcing elements need to be clearly shown on the shop drawing. For many steel cage layouts, this overlap length is specifically designed to meet a minimum code requirement. Making longer overlaps than required typically does not pose a problem besides using extra material. But a shorter overlap could be a big problem, so it needs to be avoided. For more information on reinforcing steel laps and design, see the Concrete Reinforcing Steel Institute website. It's a great resource. You mentioned bending bar. Michael, how do you determine the length of your bent bar that you're going to make?
So the key is to measure from the outside to the outside of the final bent bar. So be sure to include necessary length, including the correctly curved section, when setting the form will meet the minimum concrete cover requirements and be within the required tolerances. Lastly, when determining the total length of the bent steel bar or mat, the final length of the bent leg also needs to be determined and included. If the bent section is a continuation of the tensile steel with the required lap of another section of reinforcement. So the minimum length of the bent leg is needed to get that satisfactory overlap splice.
That's great information, Michael. One thing I might mention, when you're bending the rebar, it's important to get the right radius. If you create too tight of a radius, it may crack the rebar and be no good for you. Additionally, if you have too tight of a radius with the concrete around it, when it's in tension, it may crush the reinforcing steel. So the radius is very important. If you don't have specific product or shop drawing guidance, concrete codes such as the ACI 318 or CRSI documents provide requirements regarding the allowable minimum curve internal diameter dimensions when bending bar or wire.
It's important for employees to know the proper rebar bent diameter for each drawing. It's also important for employees to know how to adjust the machine to achieve that proper diameter.
It's also important, Michael, if they are bending epoxy bar or galvanized bar, the bend may in fact damage the coating. It's best management practices to have in place a training program to recognize the damage and how to properly repair it.
Let's go see our finished cage.
All right, let's go. Well, we're here at the cage, and you can make your cages either directly on the form or you can build them in a separate part in your plant. A critical component that you need to do if you build it in another location is to make sure that your cage is rigid enough that it can handle the transportation without moving before you set it into your form. So Michael, has there ever been a time when you didn't have the right reinforcing bar in your inventory and you had to make a substitution?
Yes, and when this happens, we have a policy regarding reinforcement substitution. And when we do this, we have to let our QC department know, as well as on the production floor. Before we even do the substitution, we have to have approval from our QC department, and it is clearly written on our pre-pour report.
That's an excellent policy. Though it may seem logical that you could always substitute a larger bar for a smaller bar, some projects actually will prohibit it. Or other projects, you have to get written permission from the owner. So it's important to have a policy like Michael just described.
Sometimes another type of substitution is whether if welded wire reinforcement can be used instead of the required rebar. And just like the required rebar size, this also has to be approved by our QC department, and sometimes even the product engineer.
Okay. All right, Michael, so let's say you need to build a cage and your form is being used. How would you go about constructing your cage?
Here at Champion Precast, we particularly like to use reinforcement cage jigs. These jigs provide the ability to construct a sturdy and transportable cage. Also, this jig adds additional speed and quality assurance by having bar placement location within the accepted tolerance range for the product. The only variable to be the bar size, which is shown on our shop detail. Additionally, this fixture can be marked to show any special layouts, such as cast openings or embedded items, lifters, etc. Along with building the cage, we also attach reinforcement spacers or chairs to the steel cage. These ensure the reinforcement meets the minimum concrete cover requirement. At Champion, our standard design is a 2-inch cover for each wall vertical and a 1-inch cover for our flat mat bottom steel.
Michael, I'm glad you brought up spacers because there are many different spacers in the marketplace. There are steel and plastic and even concrete spacers. The use of the spacer is typically the precaster's option. However, the type of product that you're going to run will usually dictate the type of spacer that you'll use.
And it's also up to the production management and the steel crew to determine on how many and where the cage spacers should go based on their experience.
Again, I suggest looking at the NPCA Learning Lab video, Reinforcement Inspection. It describes how to measure concrete cover to your reinforcing steel. It should never be less than 1/2 inch or what is shown in your project details and specification. So Michael, why don't we talk about how you conduct your overlaps and actually tie them together?
Sure. So when it comes to splices, you can use one of two methods. There's wire tie and then there's weld tacking. For the overlap and wire tie method, the adjoining steel rebar must overlap to the specified minimum distance as illustrated in the shop drawings. The distance is based on the required overlap length that we discussed earlier. When the proper minimum overlap has been established, the rebar is then held together by twisting on the appropriate wire tie or using one of the gun-based rebar tying methods. Like spacers discussed earlier, The amount of wire ties used in spacing is up to the cage fabricator. It just needs to produce a rigid enough cage that keeps its shape when transported to the form, placement in the form, and the concrete pouring and consolidation.
It's also very important when tying rebar, if you're using epoxy coated bar, that you also use coated wire ties so you do not damage the coating. In addition, commercially there are plastic clips that can make rigid cages and be applied using a applicator gun. So Michael, the next item that we have is the overlap and tack weld method. Can you walk us through that process?
Yeah, so the overlap with the welding is actually quite similar to the tie method. The only difference is we're tack welding it just to keep it in place. The load transfer between the steel bars is still accomplished by having the proper minimum overlap, and the tack weld simply holds the sections in place. Even though this is not a structural weld, you do not want the weld to burn up the connecting steel or wire and reduce the reinforcing area. Make sure you're using proper technique when making a tack weld.
Thanks, Michael, for explaining all the different ways that you can overlap and tie the cages together. I also encourage you to investigate the other methods of cage connection, such as structural welding or mechanical couplers. And if you have dissimilar metals, such as stainless steel to regular, there are bimetallic couplers to separate those. So we've now fabricated the steel, we've put it all together. How do we know that we have the right tolerances all put together?
Well, the most obvious way you can tell whenever a cage was not built right is if it does not go into form easily. If you have to force the cage in, that should tell you some dimension is out of tolerance. A force fit will introduce added stresses into the product after concrete casting and hardening.
So Michael, what about cages that are loose fitted?
Similarly, cages that are loose fitted, whenever you put them on there and the cage spacers are not in contact with the surface, they too are actually out of tolerance of the drawings. You also need to ensure your cage is rigid enough to stay in shape during the concrete casting operations. It's important that the productive supervisor or pouring crew observers the steel reinforcement to ensure there is no movement of the steel that could place it out of tolerance. Movement indicates additional spacers or chairs. Wire ties or tack welding are needed to keep the steel in place. The worst time to find out that your cage was not built right is when the concrete hardens and the form is removed. So finding issues early will not only save your product, but save you from unnecessary hardships in the future. Now it's time for QC to get the final inspection before pouring.
Well, Michael, thank you very much for showing this. We appreciate it.
Thank you, I enjoyed it.
So in conclusion, there's 5 important things to know about when fabricating steel rebar cages. One is that the steel reinforcement is critical to the structural capacity of the structure that you're making. And 2, for that steel to function as designed, you need to follow very closely and understand the shop drawings of the steel cage that you're making and keep it within the tolerances that's required within your shop drawing. Now 3, sometimes steel substitutions can be made when necessary. However, substitutions can only be made after following your company's written company policy, and those substitutions are noted on the pre-pour inspection sheets. Number 4 is that you can fabricate a cage either on your form itself or outside on a jig fixture such as we've seen. The jig fixture offers some real opportunity that you can have tolerance control, that everything's in the right space. And 5th, once you have the cage in place, give it one final inspection to make sure that the tolerances are there, the concrete cover is correct, and that the cage has been rigid enough that it will handle the concrete casting and vibration and won't move during that procedure. After that, it's all easy, so keep on precasting.